Ukrainian Metallurgical Technologies, Research and Production Enterprise. We would like to bring your attention to the report concerning increasing efficiency of the existing production by means of comprehensive approach. Our company develops and implements technical solutions which are aimed at improving investment attractiveness of project due to reducing budget of pre-planned activities up to the level of the current profitability and ensuring payback period of no more than 2 years by means of prime cost reduction and product quality improvement. We offer you the following areas of cooperation: comprehensive consideration of technological and ecological tasks, implementation of waste heat recovery systems, improvement of recycling water systems operation efficiency, and sustainable management of building and facilities life cycle. High-quality engineering and extensive use of intelligent 3D modeling enables the customer to maximally avoid unforeseen additional expenditures and not to exceed time limits during construction. Our solutions are successfully implemented at such industrial enterprises as Metinvest, Severstal, ArcelorMittal, and Solvay. One of the examples of improvement efficiency of technology with payback period of 1-2 years is the comprehensive solution for sinter production. It is aimed to increase efficiency, improve quality of sinter, and observe environmental norms. We have studied the existing operation scheme of sinter machine that is based on irreversible losses of heat caused by solid fuel combustion in sinter cake, while heat losses amount to about 40%. This technology is characterized by low capacity and poor quality of output products with approximately from 12 to 15% fines content. There are also two powerful sources of emissions in the form of stack flues that have a negative influence on environmental performance of enterprise. As a result, specialists of Ukrainian Metallurgical Technologies, in cooperation with partners and departments of the customer, developed a solution that enabled to change direction of airflow of cooling zone for easy transfer and recycling of heat received from hot sinter cooling after sintering. This enabled to improve qualitative characteristics and at the same time decrease operational expenditures, while stack flue and gas cleaning system of a cooling zone were excluded from technological cycle. This solution enabled to increase sinter workshop capacity by 30%, improve sinter quality, while content of fines with fraction from 0 to 5 mm did not exceed 5%. Hot strength and reducibility of sinter increased by 5%. Temperature of finished sinter was within 120 degrees Celsius, as well as consumption of solid fuel into burden of sinter machines decreased by 15%, and all environmental requirements were met. In order to calculate expenditures for construction and installation work on modernization of sinter production, simultaneously with development of comprehensive technological solutions, specialists of Ukrainian Metallurgical Technologies company surveyed the building of sintering facility with its subsequent 3D modeling. This enabled to estimate its current state and specify required scope of work on strengthening the building, taking into account implemented technological solutions, while probability of errors during process of project implementation was eliminated. Applying comprehensive approach for solving some high-priority tasks allowed meeting customers' requirements to decrease budget for implementation of this solution from $250 million planned for new construction to $54 million for reconstruction. Such approach enabled also to improve efficiency of the existing technology and ensure high investment attractiveness of the project with minimum payback period. One more example of improving the production efficiency of metallurgical enterprise by means of comprehensive approach is the solution for water supply and removal system reconstruction with an ensuring payback period of 1-2 years. Tasks that can be solved by means of reconstruction are as follows: reduction of expenditures for water supply and removal systems maintenance, reprocessing of slurry contained in wastewaters, reduction of consumption of fresh processed water and disposal of production wastes, stoppage of industrial waste disposal into slurry collector, and improvement of conditions of water supply and water removal systems operation. The existing water removal system makes provision for discharge of stormwater runoffs and production waste into slurry collector. After concentrations, homogenization and sedimentation of pollutants, clarified wastes are discharged into the river and sediment is pumped into slurry collector for thickening. The existing water removal system requires large operation costs. Specifically, power supply of complex requires 14,000 megawatt power per year. That brings about payment for power in amount of $1 million per year. In order to reduce operating expenditures for the existing facilities and utilities, the feasibility of water supply and removal systems of construction was proved. The reconstruction includes the following: providing recycling systems for equipment cooling, arrangement of local purification systems, arrangement of after-treatment of part of waste with their subsequent use for makeup of the recycling system and stoppage of fresh processed water consumption, return of overflow and blow of waters into recycling system, reprocessing of additional sediment on the existing facilities, plants and its usage in the production, and reduction of expenditures for power supply. Advantages of suggested reconstruction scheme are as follows: stoppage of discharge in production wastes and pollutants into the slurry collector, periodical discharge only of stormwater runoffs from the industrial site only during warm period, reduction of fresh processed water consumption for makeup of recycling systems for equipment cooling, solving of problems concerning operation of facilities and utilities, as well as reprocessing of results in slurries. Total economic benefit that can be obtained from water supply and removal systems reconstruction owing to saving of power, fresh processed water consumption, as well as the reprocessing of iron-containing slurry will amount to $1,746,000 per year that enable to prove feasibility of reconstruction with payback period 1-2 years. Also, the example of effective engineering solution is the development of unified water treatment complex for a casting and rolling module consisting of 2 converters, 2 continuous casting machines, and 3 rolling mills. The water treatment complex consists of the following: 8 recycling systems ensuring supply of water with corresponding parameters and certain quality for equipment cooling, system of return recycling water and polluted waste treatment to the required quality of water in the recycling systems with maximum use of zero discharge and non-waste technologies. The amount of generated waste concentrate is no more than 0.7% of the complex capacity. The generated slurry is dehydrated and reused as follows: iron-containing slurry in the main production process, lime slurry in the auxiliary production process. Also, the water treatment complex consists of makeup plants for 8 recycling systems of 5 types of quality: processed, clarified, softened, demineralized, desalted, and highly desalted, permeate.